In this video, we will see how to create a DSD, Dataflow, and content constraint in the SDMX constructor. In the SDMX constructor, we can create DSDs, data flows, and content constraints either by the one-by-one approach or in one go using the table modeler functionality. We will first see how to apply the one-by-one approach and subsequently the table modeler functionality. The following steps assume we already have a concept scheme created and the corresponding SDMX ML or the XML file is saved on our computer in the local folder called local_registry. Also, for this demonstration, we are using dummy data contained in two tables from an imaginary country's National Statistical Office called Demoland NSO. The concept scheme created earlier is based on the model data from these two tables. The one-by-one approach. First, we will see how to create a DSD, then a data flow, and then content constraint. We are seeing the SDMX constructor now. Click on the DSD button in the editor menu and ensure that the local folder we created before, local registry, is selected from the load from registry drop-down option. Click on the load concepts in the editor ribbon menu. In the resulting window, as you can see, select the SDMX registry. In our case, it will be local registry. Then click on load. The concepts will be visible in the concept pool. We will drag and drop the concepts from the concept pool to either the dimension or the attribute pane on the right. For our example data, except for the unit of measurement, all other concepts will be in the dimension pane. Now, unit of measurement is here. We drag and drop it in the attribute pane, and rest can go to the dimensions. Note that by default, SDMX constructor has pre-selected time dimension and primary measure on the right pane. However, ensure that the concept scheme fields in both are set as other concepts. By clicking on this, we can check that the concept scheme is empty here, and this is true also for the observation value. But if we click on, let's say, indicator dimension here, we see that the concept scheme is specified here. What we can do is we can select and copy and come back here, go to time period and paste it, say apply, and we do the same for the observation value. We paste it here and we click on apply. Now, as you can see, I have filled in the details for the DSD here. For ID, it is DSD underscore demoland underscore NSO. For agency ID, it is demoland_NSO. For the version, it is 1.0. For the name, it is DSD for the Neverland NSO. Clicking on the Export or Save button here will open up a pop-up window where we can make a few adjustments. For Use Local Concept Scheme, we will turn it off. For Output Code Lists here, we will turn it off. Also, for Output Concept Schemes, we will turn it off. Now, we will click on Run. It shows up this message indicating that the files will be merged. Click on Yes. Now you can see here a quick message confirming the creation of the DSD. As you can see, we have the XML file here, and you can see the data structure here. Now, to create a data flow, click on the Dataflow button in the editor menu and ensure that the folder we created before, local registry, is selected from the Load from Registry option here. For this example of Dataflow, we will select this table, which is unemployment rate by sex and region. Note the columns and the rows. To recreate this table, it is important to note these information. We go back to the SDMX constructor. Here we will first enter the details for the data flow. For ID, I have already typed df_UNER for unemployment rate _sex_geo. For the agency ID, I have typed demoland_NSO. For the version, it is 1.0. For the name, it is unemployment rate or UNER by sex and region. Then we click on the annotation button here. After that, click on the standard types. Then select the layout column and layout row and click on the add button here. Now, select the layout column title place here and click on select item. Now here we see that it has offered us the option to select couple of concepts here. So as per the table we saw, for the layout column, we will select sex and the time period, and we click on insert button. Similarly, for the layout row, we click here and then we click select items, and here we will select the geo here and click on insert. So this is how the interface would look like after both entries. Clicking on the save button now will result in this confirmation message saying total 2 annotations saved. Click on OK, and now in the DSD allocation space here, This is where we will select the associated DSD by clicking on the drop down button here, and we have the ID and the name here. So we clicked on this. Now we click on export or the save button here, and we save the XML file in the same location as local_registry. We click on save. It will show up this message again indicating that the files will be merged. Click on yes. You can see a quick message here again confirming the creation of the data flow. Clicking on this will show the data flow in this XML file here. You can see the data flow mentioned here, df UNER_sex_geo. Now to create content constraint, click on the content constraint menu item here and ensure that the folder we created before, that is local_registry, is selected from the load from registry drop-down option here. We will fill the details for the content constraints here. For the ID, I have typed CC_UNER_sex_geo. For the agency ID, I have typed demoland_NSO. For the version, it is 1.0. For the name, it is unemployment rate or UNER by sex and region. Then in the constraint attachment pane here, select the attachment type as data flow from this drop down, and then we select the data flow that we need for this content constraint here by clicking on this box. It is selected, and now in this area, because we are following the table for unemployment rate, we know that there are two possible values here. So we click on this append button twice. In the first row, we select the concept indicator and the value as UNER. For the next row, we select the concept as unit_measure or unit of measurement, and for the values, we select the RT for rate. Now we click on the export or save button here, and we click on save. It will show up again this message indicating that the files will be merged. Click on yes. You can see a quick message indicating and confirming the creation of the content constraint. Clicking on this will show the XML file. Now we will see how to use the table modeler functionality in the SDMX constructor, which provides an intuitive user interface for designing statistical tables and generating the corresponding SDMX artifacts such as DSD, Dataflow, and content constraint in one go. To start, click on the table modeler button in the editor menu and ensure that the folder we created before, that is local_registry, is selected from the table modeler's editor's load from registry drop down option. We can see here the concept scheme we created before. Double-clicking the concepts will load the concepts to the concept pool. Now we can select the concepts in the concept pool and then drag and drop them into various spaces here. These spaces are constant dimensions, header, side, footnotes, and table attributes, and finally measure and observation attributes. The logic driving where to drop each concept comes from our original table here. For this demonstration, we will use both the tables. For the first table, containing data on the unemployment rate by sex and region, the distribution of concepts will include moving the indicator to constant dimension, the frequency also to the constant dimensions, sex to the header, and time period also to the header space, geo to the side space, unit of measure to the footnotes and table attributes space, and observation value to the measure and observation attributes space. Note that the age remains in the concept pool. Here, with the concepts on the right side, we can apply the constraints as well. If we click on the indicator, we can choose it to be UNER or unemployment rate, because we are talking about the first table containing data on the unemployment rate by sex and region. We click on update here, and another place where we can specify the constraint is unit of measure, because it is rate. So we select on rate or RT and click on update. Now we can add the table information here. For tag, I have added UNER, short for the unemployment rate. For agency ID, it is demoland_NSO. For version, it is 1.0. For the name, it is unemployment rate or UNER by sex and region. Now we will hit the export or save button here, and we will save it without descendants. This is a message to confirm. We click on continue. The resulting pop-up asks to save the file. So we click on save. It shows up this message indicating that the files will be merged. Click on yes. Now we will see this message which confirms that the file has been created. If we click on this, we will see the XML file that got created. Now we can repeat the same process for the other table containing data on the population outside the labor force by sex and age group for 2022. We can do that by moving the concept age to the side and bringing back geo to the concepts pool. Remember, we have to also change the constraints for the indicator. This will be POLF or population outside the labor force. We click on update. Another place to change would be unit of measure. This would be not rate but person, so we click on PS or persons. We click on update, and then we will have to update the table information. For tag, I have written POLF, short for the population outside the labor force. For agency ID, it remains demoland_NSO. Version would be 1.0, and the name would be population outside the labor force, or POLF by sex and age group 2022. Then we will hit the export or save button, and we click here save without descendant. We see this confirmation message. We click on continue, and then when we see this message to save, we click on save. Again, it will show up this message indicating that the files will be merged. Click on yes, and we can see here a message telling us that the file has been created. If we click on this, we can see the XML file containing the SDMX artifacts that just got created through the SDMX constructor. Now, if we restart the SDMX constructor and access the local registry, we can see the SDMX artifacts within the tool. For example, if we click on the DSD button here, we can see two DSDs. One is DSD_age_sex. Another is DSD_geo_sex. If we click on the Dataflow button here, we can see two data flows. One is DF_POLF. Another is DF_UNER. And finally, if we click on the content constraint button here, we can see two content constraints. One is CC_POLF. Another is CC_UNER. This video has provided you with a comprehensive overview of the functionalities of the SDMX constructor to create DSDs, data flows, and content constraints. With its user-friendly interface, powerful features, and seamless integration, you now have the tool and knowledge to design and manage SDMX artifacts for your data needs effortlessly. So go ahead and start creating meaningful SDMX artifacts with confidence, knowing that the SDMX constructor is here to support you every step of the way.